Welcome to another lab demonstration video here for the 1211 lab in North Georgia. This week's lab, we're going to be taking a look at separation of a mixture. And so really what we have a white powder here that I'm going to be massing out in just a second that has three different compounds, all kind of intermixed. We have acetaminophen, sucrose, and calcium carbonate. And our goal for this whole procedure is basically to take that mixture and separate it out into its pieces. And we're going to do that basically just by figuring out kind of what the solubilities of some of these compounds are, and that's a lot of the information that's given to you in the pre-lab and some of the things that it has you look at there. And so we'll talk more about that as we get to those steps. But really our initial kind of starting point for this experiment as far as kind of collecting data is actually just going to be massing out the powder that we're going to use, massing out our evaporating dishes that we're going to be eventually collecting some of our mixture components in as we do the experiment, and just getting those masses kind of here at the start. And then I'll show the rest of our setup that we have that's already kind of heating right now. And so that way you don't have to sit and just kind of watch stuff heat. I'll just kind of show the setup, and the stuff will be preheated and ready to go for us kind of in the next portion of this. But the first thing we're going to do, we are going to mass out our white powder. So this is our mixture that has our three different components in it. And we want about 2 grams is what the procedure says. So that doesn't mean you need exactly 2.000 grams. The exact mass actually isn't all that important. All that matters is that you get something close to 2 grams and just record all of the decimals that you have. If that's 1.750, then that's fine. You can just use that amount. You see I already have a piece of whey paper already in the balance. And what I'm going to do before I actually start adding any solid to it, I want to go ahead and tear this and make sure that I get that, makes my balance zeroed out. So right now my balance reads 0, and so now everything that I add, that's the mass that I'm actually getting shown here on the display. So I'm going to go ahead and add my mixture here, again aiming for somewhere around 2 grams, and also in the process trying not to spill the powder everywhere as I do it. And so that first one is a little over 1 gram, so I want about that, probably a little less than what I just added as an additional amount. So I'm going to add a little bit more. That has me at about 1.757 grams. Like I said, doesn't have to be exactly 2. I could, if I wanted to be really picky, I could get closer to 2. I don't think that's really necessary for this particular experiment. Our goal is not to have that exact amount that the procedure says. We really just want to have the actual measurement. And now actually, as I close this thing up and it's had a chance to sit there for a second, these balances, when they're open, you can have kind of wind and other things, or air movement that can actually disrupt the balance a little. It's actually stabilized out. It's 1.761 grams is that mass. And that's actually what I'm going to write down here. So mass of our powder, 1.761 grams. And I'll have a display with kind of showing all of our measured values here in a moment starting out. And so that's it for my powder. Now the other thing that I also need masses for besides just this powder is going to be my actual evaporating dishes that I'm going to be collecting my components of my mixture in later. So for those, these have been preheated in an oven. They actually just got taken out a few minutes ago. They're just now down to kind of room temperature, so I can actually handle them with my hands. And you'll see I have labels on here of A and B. You'll see I have test tubes labeled a little bit later in the next step as well of A and B. A is what we're going to be collecting from our butanol wash, which is going to be acetaminophen. B is going to be what we're collecting in our water wash, which should be sucrose. And so for our one that we're going to use for acetaminophen, I'm going to get the mass of our evaporating dish. Again, I'm going to close all this up, zero everything out by hitting the tear button. Then I'm going to go ahead and add our evaporating dish so I can get a mass. I'll close this back up so it can kind of stabilize. And it's about 54.724 grams. So we'll record that, 54.724. And another thing I'll kind of mention here, it's actually kind of important that I've let these cool down. If you've just taken these out of an oven, one of the things that can happen with that, if these things are still hot, any hot object in here, if you kind of close up your container, you're actually going to get what's called convection from the heat being released from that hot object. And that convection is going to cause a little bit of air movement, and that air movement actually can disrupt your balance from being as accurate as it probably should be. And really oftentimes what you see is the balance will kind of skip around a lot and kind of bounce up and down as the effects of that convection. So you really don't want to measure things while they're still really hot. That's important for massing these things at the beginning, but also at the end as well, because we're going to be heating these things up as part of our experiment. All right, so that's for A. We have our mass for A. Now I'm going to take a look at getting our mass for B. Same thing, I'm going to zero it out. It's actually already still at 0, so I don't need to do anything else to it to re-zero it. I'm going to add a second evaporating dish and record the mass for this one. And this is 48.640. So again, I'm going to record that value. And now I have my masses that I need here at the start. And now the next part of the experiment is actually going to be taking this white powder and actually going ahead and starting our filtration process that we're going to use to separate everything out. And so that'll be kind of our next part that we're going to move to. All right, so now that we've masked everything out, the next step is setting up our filtration. So to get our filtration set up, we have a funnel, piece of filter paper that we'll be adding to our funnel in a moment. We have a ring stand to be able to hold our funnel in place. The liquid that we're going to be basically passing through our funnel to help do our extraction and our separation, we're going to collect then in our evaporating dishes. So you'll notice I have evaporating dish A under here right now to basically go with the butanol being the first part of our experiment. Likewise, in this hot water bath, I have two test tubes labeled A and B. The A again being the hot butanol that we use for the first part, B being the hot water that we use for the second part to extract the sucrose. And what I'm going to do to kind of set up everything before I can add my powder and really start anything, I need to get my filter paper in place and ready. So I have my filter paper, and you'll notice it's not in a very conducive shape to basically just put down into my funnel, right? I can't just kind of stick my finger down here and try and jam it down. It's just not going to fit very well and not be very effective. So most of the time, like what we kind of do in the pre-lab video, we're going to take our filter paper, and what we're going to do is we're going to fold it in half twice. And by folding our filter paper in half twice, we're now going to get something that resembles more of a cone shape. Right? It looks more like a cone instead of kind of the big large circle. And additionally, now we can do, if we look towards the edges, don't go in the exact middle, but between two of the outer little kind of flaps here, once you have it folded into that cone, if you go down in there and kind of open it up, notice I can open it into kind of a nice cone shape. Right now I have this open cone that kind of matches fairly closely anyway, the shape that I have for my funnel. And what I can actually do is I want to take this filter paper and I want to stick it to the funnel, and I want to have it kind of stay there. Right? And that's the other part that's tricky about sometimes getting the filter paper set up, because if I put the filter paper down in there and just let go, it's going to pop back up. Right? It doesn't naturally stick to the walls of the glass funnel. So how I can fix that is I can actually wet the edges or the surface of both the funnel and the filter paper, and that will actually help those things stick and kind of make a little bit better of a seal, and it'll keep the filter paper sitting down nicely inside of the funnel. Now, to do that though, I do want to be careful. If I'm adding water here at the top and I'm going to have water coming out the bottom, I don't really want any water with my first sample that I'm going to be collecting. So what I'm going to do is I'm going to switch just briefly to a beaker to collect any water I'm going to use to do this. Then I can actually just take a squirt bottle of deionized water. And normally you could do this, you want to do this with the solvent you do your filtration with. And our first step is going to be butanol. Butanol doesn't quite make as nice of a seal with filter paper in the glass. And so in this case, I'm actually going to use just a little bit of water to try and help make the seal. And so if I hold my filter paper down in here a little bit and just squirt a little bit of water while holding kind of some of the sides of the edges of the filter paper towards the glass funnel, you see now my filter paper is kind of stuck to the edges of the funnel, and it's stuck there fairly tightly. Right? It's not popping back out like what we saw before. So what I am going to do, I'm going to give this a couple minutes to drain out and dry out so that there's no more water there. And so I'm going to kind of cut the video here for a second when I do that. And the next thing I'm going to do after that is I'm going to come back and I'm going to go ahead and start adding my white powder and then actually start my filtration setup. And when I go to do that, you will see me switch from the beaker back to the evaporating dish so that everything I collect will be the sample that I want. All right, so at this point, all of the water that I used to kind of get the filter paper to stick to my funnel has drained through. I don't need to keep this water. This can just go like down the sink or in the waste. I'm going to go ahead and move this out. I'm going to readjust my setup a little bit so that the next step when I actually add my powder and then add my butanol will easily collect in this evaporating dish. And I'm actually going to adjust the height here of my funnel in a way that the tip of my funnel is going to be kind of nestled up against the edge of the evaporating dish. And so I can kind of do that here. And what that's going to do is just going to help speed up the draining process of the funnel. Because otherwise, one of the things you'll notice about filtrations like this one, it's called a gravity filtration. If we don't have a vacuum pump to kind of speed this process up, it goes very slowly. Vacuum pumps are something you'll see us use in future labs, but not this one. And so gravity filtrations like this, every little thing we can do to speed them up is good. Otherwise, you're just kind of staying around for a long time. So what I'm going to do is I'm going to go ahead and at this point, I have my filter paper ready to go. I have what I'm going to collect my first kind of portion of the mixture in. And so I'm going to go ahead and take my sample, and I'm going to go ahead and add all of it into my filter paper. And now at this point, I'm ready to go ahead and start adding my butanol for the first step of this process. Right? So everything's in here. On CSE Pub, you'll notice it does ask you for measurements of the volumes of the butanol and the water that you're going to be adding. So I'll go ahead and verbally give those now, but I'll also have a recorded sheet at the very end that'll have all of basically the measurements that you'll need just to make sure that you have all of those pieces when you go to enter things and do the calculations for the post-lab. But the volume for the A, which is the butanol, was 5.10 milliliters, and the volume for the water was 5.02 milliliters. And so those are the volumes that we'll be using, that you'll be entering to CSE Pub. They're really not that critical to this experiment. They're not going to play a role really in any other calculations, because those are just and really when you're here normally doing this lab in person, us having you enter those measurements is more just to get you more familiar with using graduated cylinders, make sure you can measure them to the appropriate decimal places, and things like that. And so that's something we have a harder time implementing here, unfortunately, online, but it's something we just kind of have to get used to. But those are the volumes, and so CSA Pub will ask you for those measurements, and again, I'll have those in kind of the final table of all the data and measurements I've made at the end of the lab. And what I'm going to do now is take the butanol, and I'm going to slowly start adding to this mixture to try and dissolve as much of it as I can that should be dissolving. Right? Not all of that white powder I just added should be dissolving in that butanol. The only part that should be dissolving is the acetaminophen portion of that mixture. Now, how I'm going to go about adding the butanol, rather than just take it and dump a bunch or just dump half or something like that, a lot of times what happens that I think is maybe the easiest way to kind of go through this, and might be slightly different than what your procedure calls for. And notice I'm going to use what's called a test tube holder here to grab the test tube out of that hot water bath. This thing's too hot for me to want to touch with my hands, so instead I can use this holder to make that a little bit easier. And what I'm going to do is I'm actually going to use a pipette here to pull up some of that hot butanol, and this way I can kind of squirt the hot butanol over all the different sides and parts of my mixture. And what's happening now is some of that white powder is dissolving in the liquid that I'm adding, and that's what's going to start dripping down through the bottom here in just a moment. That is unfortunately a little bit of a slow process, so we're going to have to wait. And what I'm going to do is I'm going to wait till I see a decent bit of drips come through, and then I'm basically going to go through and I'm going to add another pipette full, and at that point I probably won't have much left in here, and I'll just go ahead and dump the rest of the contents of the test tube over the top of my sample to dissolve the rest of my acetaminophen that hopefully will dissolve. But at this point I'm going to add a little bit more with the pipette, just as much as I'm going to be able to pull up here from the pipette. And what I'm trying to do, and part of the advantage of the pipette, is as I squirt the butanol down from the pipette, I can make sure I cover and hit all of the parts of my mixture. Because when I first added the powder to the filter paper, some of it stuck to some of the edges here. And so I'm just trying to make sure I cover all of it so that all of the powder gets exposed to this hot butanol, so that any acetaminophen anywhere in that mixture hopefully is going to dissolve in this hot butanol and then eventually filter out down through the bottom. So I'm going to add this and probably 2 more little bits from the test tube at this point. Since I do have pretty much all of it covered, I'm going to add a little bit. And I'll wait just a second here for a little bit more to drip through, and then I'll add the rest. And then I'll probably cut the video because the rest is going to be sitting here waiting probably 5 to 10 minutes for all of the acetaminophen to drain. And then once all the acetaminophen has drained through, then I'm good to go to my next step, which is basically switching evaporating dishes that I'm collecting things in and adding the hot water to try and get the sucrose. And I'll take this acetaminophen dish, and I have another hot plate set up similar to kind of what I have here in a hood that I'm going to heat really hot. I'm going to boil off all the butanol, and that way basically what I've done is by dissolving any of the butanol in my mixture, dissolving any of the acetaminophen in butanol from the original mixture, that acetaminophen is getting transferred down here to this evaporating dish, that when I heat off all of my butanol, all that's left is acetaminophen, right? That's kind of our goal here, is we just want to separate the 3 things that were in that original powder. The acetaminophen is the first one we do that with because it's the only one that should be dissolving in this hot butanol. So I'm going to go ahead and add the last bit of the hot butanol at this point, which isn't all that hot probably now, which is still okay. And I'm just going to wait for this to finish draining, and then I'll come back with the next clip. I'll show you switching things out and getting ready to do the next part with the sucrose by adding the water. All right, so where we're at right now, all of our butanol is now filtered through. And now what I'm getting ready to do is basically kind of switch evaporating dishes, because I'm going to switch what I'm adding, which is going to change, hopefully, which component I'm basically pulling out of my mixture. Right, so we've added the butanol, all of the butanol has come through. We see we have an amount of liquid here that's come through with our butanol, and hopefully all of our acetaminophen as well. So I'm going to switch and add now our other evaporating dish underneath instead. So evaporating dish B. This is what I'm now going to be adding water to my solution for, which will hopefully get the sucrose to come out. And what I'm going to do with this in just a moment is I'm going to go take it on the hot plate, and I'll show you guys what that looks like here in a second. But I'll probably actually just heat both the butanol and the sucrose solutions together. It might just be easier as far as a taping demonstration goes. If you were doing this in person, we'd probably have you start heating the butanol right away and then start heating the water. Butanol does take a while to evaporate, but you do want to take caution with both and keep an eye on both. And so I'll talk about that in the next portion of the clip. But for the rest of this, then for this portion, we still have to add our hot water. So I'm basically going to do the same thing that I'd done previously. And so I'm going to go ahead and use the pipette to get a little bit of it, hopefully. Bring it down far enough to get enough of the water. And then what I'm going to do is just make sure that I'm covering my solution with the hot water. because at this point, if I'm looking from above, what I see is basically a dry powder. There's no liquid, so I want to make sure I get all of that powder covered with the hot water, so the hot water has a chance to basically pass through all of my sample as it's kind of just gravity just pulls it down through. And that'll give the chance for our sucrose to hopefully then dissolve in that hot water. I'm gonna add just a little bit more with the pipette. I didn't really get a whole lot there to add, so I'm actually just gonna go ahead and pour a little bit to get a little more water in there. And as I pour, I want to try and kind of distribute around the different sides. So again, I keep everything kind of fully covered. I have a tiny bit of water left that I'll add here in just a second once more of this is dripped through. But if you were looking above, you'd see the water starting to drip through. That's a good thing. That's what you want to see at this particular point in time. And you are still going to have some white solid that doesn't dissolve. In fact, you may have a lot of white solid that doesn't dissolve even at this point. That also is not a bad thing. Remember, we have 3 components to this mixture. Acetaminophen dissolves the first time we add a liquid, which is the butanol. Sucrose is dissolving in this step as we add the water, but that means that the calcium carbonate, that third component, doesn't dissolve in any of those solvents. It basically just stays there as a solid. And so hopefully we should have some white solid left at the end of this. That's going to be our calcium carbonate, and we'll have a way to kind of check that at the end as well. We'll add some HCl that I have sitting back here that will hopefully help give us a visual indication that what we have is calcium carbonate. That'll be kind of one of the next things that we get to. I'm going to add the last little bit of hot water here. And probably cut our clip off again because really all the rest of this is just sitting here waiting for the water to drip through. So I'll kind of save you the 5 to 10 minutes of wait time and kind of show you what things look like here at the end of this step and then show you kind of how we go about removing the liquids so we can get our actual solid products for the end of everything. All right, so at this point, all of this water looks like it's finished draining. And so what I'm going to do is kind of a couple things here. I'm going to go ahead and take my sample that I've been collecting out. So I have my 2 evaporating dishes right now, A and B. I'm going to be moving those to a hot plate in a moment, and I'm not going to do this one, I'm actually going to do it in the hood, mainly because butanol as an organic solvent, you really don't want to inhale a lot of butanol vapors if you're boiling all of that off. It's not like really organic compounds in general, you don't want to be inhaling them. And so as a result, I will be taking it to the hood in a moment to actually basically heat away all the liquids for both of these. But for now, what I want to also check is what I have left. So to demonstrate this, I'm going to kind of hopefully give this a little bit better of a view here. Hopefully what you should see at this point in our mixture is that you do still see there's white powder left in the filter paper. And what I'm going to do now is I'm actually going to add a little bit of hydrochloric acid. And ideally all that should be left of our mixture is calcium carbonate. Right? The acetaminophen and the sucrose should have been collected in our washes that we've already done, our extractions. So now what I'm going to do is add a little bit of hydrochloric acid. And if what's left is calcium carbonate, we should see a lot of bubbling and foaming. And you can almost probably even hear the hissing, hopefully, on camera as it happens. Because what's going to happen is that hydrochloric acid is going to react with our calcium carbonate in an acid-base reaction. The HCl react with the carbonate. It's going to make carbon dioxide gas as one of the byproducts. And we actually will then, that's what you kind of see bubbling out from that reaction. So hopefully we should visually be able to see it, maybe even hear it as I do this. So what I'm going to do, I'm going to take our HCl that I have here. I'm going to take just a little bit. And notice I definitely have my funnel in a beaker here to collect anything that comes through. But I'm going to add my HCl. And there you can see and hopefully hear as well that bubbling and kind of foaming and fizzing that's going on there. That's indicative that we have calcium carbonate there. It's reacting with our HCl. So hopefully most of what that powder is calcium carbonate. Now, we are not going to mass what's in here or try to basically dissolve all of that for the calcium carbonate. We are going to get this final calcium carbonate mass by basically just subtracting out however much acetaminophen and sucrose we get from the first 2 parts, from whatever our starting mass was. So that's how we get the calcium carbonate. But that, I just wanted to give a nice visual demonstration there. It's kind of a confirmation that calcium carbonate should be most of what's left by seeing that kind of bubbling effect with the HCl. And now what I'm going to do is I'm going to take these 2 solutions over inside the hood. And so I'm going to cut the video here for a second. And then I will show kind of what our setup in the hood looks like for heating these solutions. And you can have kind of a general before picture before I start heating these things of just the solutions from kind of an overhead view. And then I'll give you guys some overhead views of once everything is evaporated off. Again, I won't make you guys sit there and watch a video clip that's 15 minutes long of just evaporating things. That's horribly boring for everybody, so I'll get you some kind of before and after clips of what this looks like, as well as probably some clips of what it looks like if you're not careful while heating. If you burn some of these compounds, you'll see some kind of brown solids instead. But that'll be our next portion. All right, and so what we're looking at here, I've now taken our 2 dishes, evaporating dish A and B, that have our acetaminophen and sucrose respectively, and we've taken the solutions, right, of the butanol and the water and put them on a hot plate. And what you're looking at here, basically this is before we've started heating, or they've been heating for maybe 30 seconds. And so they're both just look like you have some liquids down actually in those evaporating dishes. So I apologize for the unsteadiness of the camera here, but you can see the liquid if I kind of move things around in each of these. Again, apologize for the camera unsteadiness as I do this. But as I kind of move them around, you can see the liquid move around there as well. What we want to wait for is for all of the liquid to evaporate from both of these dishes, and then actually look at what's left as far as the solids, because that's going to be then our acetaminophen and sucrose. Hopefully what we see for each of these are white powders. If they get overheated a little bit, though, we will see some brown coloration. That's not that uncommon for a lot of these, just because in order to evaporate off all the liquid, sometimes there's enough heat there to also start decomposing the sucrose or acetaminophen a little bit, and so we'll get some brownish color. So if we see that, that's what that's from. Ideally, though, hopefully we'll see mostly white solid that gets left as we boil off all of those solvents. All right, so I just want to get kind of a midway point here in the drying to kind of show you guys what's happening. So on our basically dish A here, you can see kind of some white solid. There's a tiny bit of liquid still at the bottom that's actually maybe starting to get a little bit of brownish color to it. That's okay. So this solution is probably actually almost done already. And then for our water solution that had the sucrose in it over here, if I take and shake this a little bit, you can kind of see there's still some water, but you can kind of see some glistening shine of some white solid that's already formed in it as well. And so it's not quite done yet, but it's getting there. They're actually both very close. And so I'll give you kind of another final picture here in just a little bit once they're done drying. And then what I'll do is I'll give you just basically probably a table full of all of the data and the measurements. I won't make you watch me mass things. I think by this point, with the previous video and this one, like using a balance, it's usually pretty straightforward. So I'll probably just show like a final table of all the final masses once I get you a final picture of what the dried samples look like. All right, so what I want to show here is kind of what the final products look like now that I've had a chance to kind of take them off the hot plate and get their mass. If you're looking at them, there is still some brown color to them, but there's no more solution. You probably see like some shininess, but notice how there's nothing moving really in that solution as I kind of angle it around. You can see the light shine off everything and reflect. That's a good sign. It means everything's dry. A lot of it's crystalline. There is unfortunately a bit of a brown color to both of these. That's kind of almost unavoidable. If you heat it enough to get rid of all of your solvent, long enough to get rid of all the solvent, it's likely that if there's some sucrose there, it might decompose. So we probably do have a little bit of sucrose even in our acetaminophen sample. And if we look even at the sucrose sample here, it's almost like caramel if you're looking at it, right? In some ways, the kind of that brownish color, it's really what you effectively made. You kind of almost caramelize some of that sugar when we've heated it up maybe just a little bit too much. There is some kind of white reflectiveness. If you look around the edges where I'm trying to kind of shine some of the light, you can see some kind of the little bit of the solid that's deposited there and how it reflects light. But the biggest thing is they're all solid all the way through. There's no more liquid really in either one of those. And so those are our final samples in terms of what they look like. And like I said, that little bit of brown, that kind of happens. If you want to see what it looks like if things get charred way too much, here's a sample that if you leave it on for a significantly long time, that's a lot of charred sucrose in this case. And so it can look much worse. If you get that black color, you've definitely heated it too much, too long. That's what we wanted to avoid, which we avoided that here. So a little bit of brown, we just kind of live with it and move on. But what you see here is all of the data that I've collected for the lab. So this should be all of the actual numerical values you need to be able to put into CSE Pub as you're doing your calculations that are measurements that you make. Everything else is calculated from these values. Now, these two volumes here, we have 5.10 milliliters and 5.02 milliliters for the hot butanol and hot water. You won't use those values anywhere in calculations, but like I'd mentioned previously, CSE Pub does ask for them, so you will want them. The biggest thing there is it's really probably just trying to get you more familiar with using a graduated cylinder, and the fact that if you have a 10 mil graduated cylinder, you can probably measure it out to the hundredths place for that volume. That's kind of the important thing that we normally try to highlight with that measurement. Since you're not making the measurements yourselves, we unfortunately lose a little bit of that, but that's why those measurements are there. All the real values you need calculation-wise are the first 5 that you see here. And so we have a mass of evaporating dish A, along with the mass of basically this final mass with the product in it. And then for our second evaporating dish B, we have its initial mass and then the mass of the product, so with what's in it now. And you can take the difference for each of those pairs to figure out the mass of acetaminophen and the mass of sucrose, respectively. And then we have the mass of our starting powder here. And if you take the mass of this starting powder minus the mass of acetaminophen and sucrose you got from the first 2 parts, that should give you then the calcium carbonate mass. Now you have masses for all of our different components of our mixture. And from that, you should be able to do all of the remaining calculations in the experiment. As far as anything else, the rest of the lab-wise, the rest of this, we do have ways that we can kind of dispose of things. Sucrose is fairly water-soluble. If you've caramelized a little bit too much, it's less so. So you may have to use some other heavier cleaning agents to get things off. But otherwise, most of the rest of the stuff you can get out with water. Acetaminophen, if we're using large amounts, not something you really want to put down the sink. It is Tylenol. But for us, if it's really small amounts, we could get away with it, but really probably all of this will just collect in a waste disposal at the end of the lab. Since you're not here in person, not something we have to worry too much about at this particular point in time, but it is something I want people to be kind of aware of and in a habit of. Whenever you're doing an experiment, when you're done, how do you clean up? more often than not, if you've used any kind of chemicals that aren't just everyday things that you would use, like, you know, in a sink, where things could just go down the sink into the normal water supply and be treated properly, which in our case is almost everything we use really for lab is probably not going to fit that, outside of the occasional simple things like maybe sodium chloride or something of that sort. And so in our case, we're always going to have some kind of waste that we collect things in at the end. Just something I want to kind of make sure people are aware of, but again, doesn't affect us terribly much right now when you guys aren't in the lab doing the experiments yourself. But since this is 1211, odds are you'll probably have hopefully a face-to-face lab for 1212. In that case, it's going to matter more to kind of pay attention to those things and make sure you kind of know where you're supposed to dispose of things at the end of the experiment. But that's all I have for this week. We'll catch you next time for our next online lab.